So I'm Aaron. Thanks, Ashley. Thank you all for coming. It's really cool of you to be here. And yes, I'm going to talk about Athens today. So to get started, who has used Go modules, the dependency system, before? Oh, yes, you're in the right place. Who's heard of module proxies before? Also called module mirrors. Okay. Who's used one of them before? Cool. Well, this is going to be for everyone, except for you, because you raised your hand. No, I'm just kidding. So yeah, we're going to talk about module proxies, but also specifically about Athens, which is a module proxy implementation. We're going to kind of start with modules and why module proxies are useful, and then we're going to dive into specifically the place that Athens fits in this whole ecosystem of module proxies. So this is my hot take to begin with. I would argue that until we had modules, the dependency management and package management space in Go worked very well, but it was very fragmented. We had, by my count, I think we had at least 4 different tools, all of which did a really good job at dependency management, but they all did it differently, and there was a lot of confusion, and there were tribes of folks. Some like this one, tool A, some like tool B, some like tool C, and so on and so forth. And that was a problem, right? Because we couldn't all settle on one good solution. So I like modules because you don't have to use the Go path. But I also like modules because it is one good solution that we can all start agreeing on. Okay, so I'm shallow, so like I said, we don't have to use the Go path anymore, and I love that. But I also love, and I think it's super valuable, that Go modules and the whole dependency story for Go is now built right into the Go toolchain. So when you do a Go get, a Go build, a Go run, a Go install, all the way down the line of all those subcommands in the Go CLI, those all are dependency aware now as of Go 1.11. And that also means that Go modules introduce some new functionality, so you don't need to have a vendor directory if you don't want to. And I have not done Go modules any justice on this slide, because it is one slide, but I did put a short link. So there's tons and tons to learn about Go modules. If you don't know about it, or you've used it a little bit, and you want to know more about it, I would highly recommend going to checking out that short link. That is to the Go modules wiki. There's tons and tons written, and really there's just tons of design by smart people that's gone behind Go modules to make this thing a really great tool to use. So we're gonna move on though from the Go modules technology, and we're gonna move on to how do we actually get the code for the Go modules system to figure out what your dependencies are. Okay, so I mentioned that it's built into Go get. It's also built into a lot of other commands. But fundamentally, when you do a Go get to some package name, github.com/Aaron's awesome package, you're going up to github.com, the VCS, the version control system, and you're getting the code directly from there. So that can be great, and it has been great for the whole time that Go get has existed in Go, which has been a very long time. The reason that's been super good is, first and foremost, when a developer goes and checks in some code, maybe merges a pull request, maybe even tags a code in a GitHub release, tags a commit in a GitHub release, that code is immediately available for anyone in the ecosystem to use. So they can do a Go get, they'll get down whatever that version is in GitHub, or maybe they're going to be using Glide or Dep or any of the other awesome dependency management systems we've seen in the past. And all of those are going to go right to GitHub, and the workflow for both sides, for the consumer of the dependency and the author of the dependency, is pretty seamless. You don't have to learn any new tools. You just git push if you're the maintainer, and you do your Go get or your Dep pull or your Glide pull or whatever else. And that just does basically a git checkout and changes to a specific git tag. How's the flickering doing for people? Are you memorizing each, and then you go to the next, it's like a slideshow kind of? Okay. Let me know if it's getting too fast, and I'll just start. D-I-R-E-C-T, I'll spell it out so everyone can. But we've always sort of had this problem brewing a little bit under the surface of this whole system where we Go get directly from the version control system. And it's more than what happens when someone does a git force push or a git push -f. But what we're really saying here is that if you do a go get, or you use glide or dep or something like that, at a specific check-in SHA, a specific git SHA, for example, if you're using GitHub, and then later on, someone who's maintaining that package does a force push to that SHA, they can completely change the code out from under you, like completely. They could also just delete the repository and then it's gone forever. Or even worse, this might be the worst one, is someone could delete the repository and someone else could take that repository name, recreate it, and you can end up pulling brand new code. So you could be pulling code that ends up sending everyone's credit card number to my server. So watch your credit card statements next month. So there are quite a few problems in here that arise out of pulling code directly from GitHub or directly from GitLab, etc. But they all are under this class of problems that happens when you start pulling code directly from the source of the code where someone is actually maintaining it. And that is because Git, GitHub, Bazaar, GitLab, so on, those are all designed for fast iteration. They're designed for someone coming up, making a change in the open source community, merging a pull request, doing releases, fixing security patches, and so on and so forth. Well, that's not really what we want if we're depending on that package. We want stable versions. And we want to know when there's a new version that we can pull. We want to know what that fix is, and so on and so forth. So there's overlap there, but we don't want that volatility if we're depending on a package. So how are we going to fix that? Well, if you read all the documentation about modules, it says a ton of awesome stuff, but right in there, somewhere in there, there's a section that's called the Module Download Protocol, or the Module Download API. And this is a REST API. Who's heard of HTTP? Yeah, raise your, you've all heard of, I know you're lying, you've heard, you're just too lazy to raise your hand. That's okay, I get it. But this is an HTTP API. So we all know how to use HTTP. There's tons of technology out there that allows us to do cool stuff with HTTP. And this is not a GitHub API or a GitLab API. This is a new API that's specific design for Go modules. So now that we have this API that allows us to interact with modules and download modules, figure out what the versions of a specific module are, and more than this, we now can design systems using this API to abstract away all that volatility and allow the package maintainer to keep their workflow, all of their pull requests and open source contributions and all the cool stuff that we're all used to and we all know and love. But we can now use this to act as that abstraction layer to give us, the people who rely on those packages, some of that stability that we've all been looking for. And that might look something a little bit like this, right? Before we had go-get that was pointed directly to those version control systems. But now we put a CDN, a content delivery network, in the middle. And at its very core, that is an HTTP server. And so that's a little box there, but it does a ton of stuff. Okay, I mean, if you're using a cloud provider, that can be a globally distributed, basically a globally distributed object storage system that serves up every single module under the sun. And there are some providers out there that do that, and I'll talk about that later. And that thing can be the abstraction. That thing can be the thing that makes sure that new releases of modules are tracked, that no new releases get deleted, that if something happens with a security patch, that everyone kind of gets warned that they should upgrade. There's a ton more stuff that happens there, and it's all because of this. It's all because this HTTP API gives us that abstraction layer. So then the question arises, well, we've got this awesome CDN type thing that we can build, and we can provide these globally distributed module proxies, or sometimes they're also called module mirrors. So how are we going to organize these? This is not a technology question now. This is a community question. So we definitely need these things to be reliable. Otherwise, we don't get those stability guarantees that we were just talking about. We also need to tell people where to find them. I can't just go to someone and say, oh yeah, use the module mirror. Where's the module mirror? Nobody knows, right? So you need to have this thing be discoverable. It needs to have a common name that everybody knows. But the catch is, we need to do all of this without having this thing be a central single point of failure, otherwise known, to me at least, as a single central registry. Why, might you ask? Well, who writes JavaScript? Who's written JavaScript? Okay. If you haven't heard about this, this is called the left pad incident. What happened was, in the Node.js community, there is NPM, the Node Package Manager, and that has a main registry, which I refer to as a central registry. It's at npmjs.com. And there was one little 11-line program called leftpad that was an underpinning to tons of massive dependencies, think like React, big libraries that tons of people use. And for non-technical reasons, it accidentally got deleted from NPM. When I say accidentally, I mean it got deleted on purpose for legal, non-technical reasons, but no one really understood what that meant because so much stuff was depending on it. So once that thing got deleted, npm pull, essentially the same thing as go get for npm, started breaking for lots and lots of code bases. Think everything that uses React, which is like social networking sites and things like that. And so when it says almost broke the internet, it really means almost broke the internet. It's not like hyperbole. Okay, so this is why we don't want that single central point of failure. But getting the discoverability, getting the reliability, but not having a single central point of failure, those are at odds. It's kind of going to be a little bit hard to do that. So let's look at how. Who's heard of the term federation? Who's watched Star Trek? Okay, there's some overlap there. Federation is basically the principle of taking, in this case, taking this technology and letting a lot of parties run it. And letting all of those parties work together to make this module system, this delivery system, a commonly understood concept, and therefore make it be discoverable and reliable. This is more complicated, of course, than just spinning up a single server in the cloud and making everyone use it. But this is the reason why it's worth it. We want to avoid this in the Go community. And Athens is just one part of the way that we're going to do this. So who has heard of the Go module mirror up at proxy.golang.org? Okay. Has anybody heard of gocenter.io? Okay, we've got one. Gocenter.io and proxy.golang.org are both centrally hosted module proxies, also called module mirrors, up in the cloud. So they are discoverable. You can point your Go toolchain to one of those URLs, and it will use Go modules to grab dependencies from one or both of those download servers. Okay, so that's great. But there's also the question of private code. Those public ones don't know about your private code, and that's where Athens comes into play. So Athens fits into this ecosystem of module mirrors or module proxies because it can sit inside of your firewall, and it can sit there with access to your private GitHub repositories or private GitLab or so on and so forth. And then even further, Athens can then talk up to one of those public proxies to get all those public dependencies that you need inside of your code base. So to boil it down to one word, Athens is on-prem. That's actually one word with a hyphen. So technically, I'm still with one word there. Okay, so if you think of Athens as on-prem, in the Java world, Athens would be Artifactory, let's say. And then those, Flickr. GoCenter and proxy.golang.org, those would be the Maven Central in the Java world. And you can make these similar comparisons in other technologies as well. But federation comes into play here because all of these systems, the GoCenter, the Gopher, proxy.golang.org, and Athens, they all speak that same API, this module download API. That is the thing that allows us to be federated in the ecosystem. And again, you can point GoGet to Athens just as you could point it to GoCenter or proxy.golang. And go-get uses Go modules, so anything that implements that protocol will work. Now, the way that Athens works is that if you do a go-get to Athens, it will take your go-get request and look in its own database to see if that module is there. And it can fulfill your request for that code. If it's not in storage, it treats it essentially as a cache miss. Now, Athens is not a cache because it doesn't evict entries, doesn't evict code. But it essentially treats it as a cache miss. And if it sees that case, then it will go to what's called an upstream. Athens can be configured with upstreams either as the VCS itself or as one of these proxies. And in either case, once Athens fetches that code for you, it stores it in its own storage forever. And that's where that reliability comes in. And Athens calls this immutability. That's a very important piece because you get the reliability. So we're going to do a demo. We're going to use, I wrote a little web app that shows kittens and dogs, so for both sides of the room. We're using Gin, the web framework called Gin. And I'm going to be super awkward, and I'm going to sit down, and I'm going to probably put the microphone on the table and lean over a lot so I can talk and everyone can hear. You guys ready? Everybody ready? Okay, cool. So first things first, I've deployed a Athens proxy up in the cloud for my own use. This is for demo use. Now anyone, thank you, Ashley. Anyone can use it, but I would not recommend this for production. Now this proxy is located there, athens.azurefd.net. And I deployed this a couple days ago, and it has a bunch of modules filled up in its storage. Now if we check out this code base, it's a pretty simple handler. It follows almost none of the rules that Matt just talked about in his previous talk, so ignore all of my code. But the basic idea is I've got a kitty, a pup, an index, and then my static handler for images. And then the interesting part for this talk is that I've got dependencies. This only shows Gin as a dependency, and the module's subsystem is going to figure out what packages in the ecosystem does Gin depend on. And we're going to see when we do our build that it's going to download a lot more modules than just Gin. Okay, so first thing I'm going to do is I'm going to run this build using that server as my dependency proxy. First thing is I'm going to delete my local cache of modules. So now I'm going to force everything to be downloaded up from the athens.azurefd Athens. I'm going to do my go run. And like I said before, modules is built into tons and tons of commands in the Go CLI. Go run included. So let me clear the screen here. And let's cross our fingers for Wi-Fi. Oh. And if this doesn't work, I actually have a backup plan, which is actually going to show how much Athens shines as an on-prem solution. So what we see here is we see finding, a bunch of finding. Now this is the module subsystem figuring out what besides Gin, or what are the transitive dependencies of Gin do I need to download. It contacts that server up in the cloud to get the metadata about every one of those modules. And then it starts downloading the code. Sweet. It ends up downloading zip files, and that's why you see extracting. And now the thing's running. So let's just go check out the thing. It's pretty awesome. What did I run it on? 8080. All ready to be blown away? Yeah? All right. Yeah. Raise your hand for cats. Okay. That's the cat you want in your house. All right. Now let's check out some dogs. Yeah. That's not the dog you want in your house. All right. Okay, so that's sort of the first part of this. Now the second part is, okay, that's not that exciting. We have a thing in the cloud, great. But the second thing is, let's run our own Athens. So Athens, the technology has a great documentation site, if I may say so myself. And it allows us to run our own Athens. Now there's a bunch of different ways to do it. I'm going to use Docker to run the Athens myself, and I conveniently have queued up the command here to do it. We're running Athens now on port 3000 locally. And I'm going to go and delete my cache again. That's my local cache of modules again. I'm going to point my toolchain now to the local Athens, again with this go proxy environment variable. And now I'm going to do the go run again. So we're going to see the same output on this terminal tab. And I'm going to make it bigger so we can really see what's going on here. It's going to be a little bit slower because now we're doing git clones over the network. So you can see some findings here, and this is the exact same output as we've seen before. But going over to our Athens, now we're seeing Athens doing some stuff for us. It's downloading these .info and these .mod, and everything's going sort of slow, but kind of cool. And this is literally in the background doing git clones, or basically those go gets against GitHub and GitLab and so on and so forth. Right? So this is the non-reliable part. But after this is done, we're now going to be reliable because this stuff is stored in Athens storage forever. It's immutable. So, getting there. And to ruin the surprise, the next demo, the final demo after this, I'm going to turn off my Wi-Fi, and I'm going to make this build happen again. I'm going to turn off my Wi-Fi, I'm going to delete that local cache again, and then I'm going to run the build again against this Athens. And we're going to show that the build works, and then we're going to hope that my slides still work with the Wi-Fi off as well. That's the magical part, to see if my slides still work. All right, so this is going slow. It's done. So we've got our same app running. We're looking at dogs. That's pretty cool. All right, we're going to exit out of the app. We're going to turn off the Wi-Fi. We're going to delete our cache. We've still got it pointing to localhost 3000. I'm going to do the run again. Clear the screen. There's one thing I want you to check out when I do this. Check out how slow this build is. Okay, that's actually slower than I was hoping. But still, it's pretty fast, right? Because we're going to Athens storage that's on localhost. In this case, it's disk storage, but Athens has a ton of different plugins for storage. Okay, so I'm going to wrap up with, oh, yeah. The magic is not here. Luckily, I also have a backup for that. Yeah, see, now I'm getting this half of my commission here. Yeah. All right. So really quick, I just wanted to point out a couple of really cool things that we saw kind of here, but they were under the covers. Like, we just saw some go builds and go runs, but there's some implications here. So first of all, we talked about the immutable storage and the reliability. That kind of gives us sort of a, thank you, Ashley. That kind of gives us sort of a works on my machine type of thing going on. But also, remember we saw how fast that build was the third time I ran go build? That's because of these sizes here. So I checked out 2 of the largest Go code bases out there. They come with a lot of baggage because they come with a lot of history, like literally git commit history. So Kubernetes weighs in at 837 megs at tag 1.12.1, but the module system sends down zip files. So check out that difference in size. And the same deal with Cockroach. Check out those differences. If you then extend this to put a CDN up and put those zip files in a CDN so that they're pushed out to the edge, now we're talking about some real benefits of speed. I mentioned private code, but Athens also comes with some enterprise-y features that are actually really useful for tons of teams. You can audit modules, you can exclude them if they don't adhere to your CLA, and so on and so forth. And then a few other mentions here. Athens, like I said, is built on open APIs, and it sits as part of this big old ecosystem. We touched on this ecosystem, but I wanted to show this awesome drawing because it has trees. So we can see Go Proxy, Go Center, Artifactory, and so on and so forth. And there's a little bit more to the ecosystem, a lot more that I can talk about right now. There's a couple projects here that I want you to check out. The slides will be up for these links. And especially check out Julie's talk if you weren't at it. It was in this room. And Julie talks about a ton more around this ecosystem of Go modules. A final call to get people involved. Please check us out. You can tweet us at @GoMods. We have a Gopher Slack channel. We're super friendly there. And our motto is Chill Open Source Projects FTW. That was coined by one of the core maintainers. We really love to have you. We're super welcoming. We make it a point to welcome each and every one of you personally when you come into the channel. So whether it's coming to say hi, coming to fix a bug, whatever it is, we would love, love, love to have you. If you have any questions, tweet me anytime. My DMs are open as well. And I want to thank @Franzia, who is also my wife, for all the awesome drawings and diagrams. So thank you, everybody.